Here we go. Okay, so do you remember from last week? Somebody tell me what. We never defined the word, but we talked about algorithm. What is an algorithm? Mm-hmm.
Is it like the layout?
Well, okay, layout. Okay, so what else?
A set of steps to help you find answer a problem.
Absolutely. I love that definition. A set of steps to help you find the answer to a problem. How many of you like Rubik's Cubes? Okay. If you go online and Google on YouTube how to solve a Rubik's Cube, guess what you're looking up? An algorithm. Okay. Like we talked about last week, washing your hair. Once, wash, rinse, repeat. That is an algorithm. So we're going to define it as a step-by-step process to solve a problem. Now, that doesn't just mean a problem in math. Could be a problem in a Rubik's Cube. So, with algorithms, we've already talked about this year. We have the traditional algorithm for multiplication and division. We're going to use that same algorithm with multiplying decimals. But there is one rule about decimals that we do differently when multiplying that we don't do with adding and subtracting. What is that? What did we say yesterday?
You put the longer number on top.
Yeah, with multiplying, absolutely. I think it'd be smart to put the larger number on top, or the longer number. What else?
You don't add a zero at the end.
Okay, absolutely. We don't have to fill in any zeros. But because of that, there's one other thing. What did we do yesterday? What did we have to do yesterday?
Bring down the decimal.
Well, we had to bring down the decimal, so we're not going to do that today. Why did we highlight yesterday?
Line up.
Okay, but guess what? With multiplying, you do not, and I'm putting this in all caps, you do not line up decimals. You do not. With multiplying decimals, you do not line them up. Adding and subtracting, we have to. It's super important. But multiplying, we do not line up the decimals. Okay? Now, right here it says, place the longer. Now, like Eva said a second ago, I think you actually said larger. We're not looking for the larger value. We're actually looking for the longer number, the one with the most digits. So between these two, which is the longer number? 9.7 is larger, but what's the longer number? 1.58. We have more digits in 1.58. So we're going to put that one on top. 1 and 58 hundredths times 9 and 7 tenths. And if you'll notice, I did not line up my decimal points. I'm just writing it, putting 3 digits times 2 digits. I honestly could completely ignore my decimal points. I could not even put my decimal points right now. I could put 158 times 97. All right? So now, the second thing we're going to do, multiply using our standard algorithm. So that means, what's 7 times 8? Okay, so we put our 6 and carry our 5. 7 times 5? Plus 5 gives us 40. What's 7 times 1? Plus 4 is 11. Okay, so I'm done multiplying with my first digit. What do I put on my next line? I've got to put a placeholder. So now I can say, what's 9 times 8? So we put our 2, carry our 7. 9 times 5? Plus 7 would give us 52. Okay, carry our 5. 9 times 1? Plus 5 gives us 14. Okay, at this point, I'm going to add them together just like I've been doing with multiplying. 6 plus 0 is, and then we have 2, 1 plus 2, 3, 1 plus 4, and 1. Okay, am I done? No, because I don't think, if I have almost 10, if I were to round that 9 and 7 tenths, that's almost 10, and that's almost 2, right? So I'm basically looking at approximately 10 times 2. If I multiplied 10 times 2, would I get 15,000? No. So our answer right now doesn't make sense. So that's where step number 3 comes in. This is your main process with multiplying decimals. We have to move the decimal over the number of digits behind the decimals in the problem. So let's look at this. How many decimal places are behind the decimal in this one? 2. Okay? I'm going to draw a little square out here. There's 2 here. How many decimal places behind this one? 1. Okay? So, in my answer, how many decimal places should I move? 3. Now, guys, you always start from the back. So, here's where my decimal starts, and I'm going to move it 1, 2, 3 times. Now, 15 and 326 thousandths. Is that closer to what we estimated as 20?
Yeah.
Absolutely. Okay? It is super important. You are moving your decimal, the number of places that you have in your problem. And always start from the back. Let's put that little note down here. Always start from the, let's say, right. We're going to start from the right side and move backwards. Okay? Let's do a couple of problems together. Which is my longer number in number 1? They are both equal. Yeah, I have the same number of digits, so it doesn't matter. Although, if they have the same number of digits, which way do you think would be easier to multiply? I'm going to agree. I'm going to put 13 and 95 hundredths on top because, guys, I'd much rather just multiply these 4 digits by 7 and have zeros for the rest than have to do the other. So it's 0.007. Again, my decimals do not line up. What if they happen to line up? Is that okay?
Yeah.
It absolutely is. If they do line up by accident, it's perfectly fine. But you don't have to line them up. All right? We actually don't want to line them up because we don't want to add extra zeros or extra numbers that we have to multiply. So, what is 7 times 5? 35. We're going to carry our 3. 7 times 9? 63 plus 3 gives us 66. 7 times 3? 21 plus 7? Oops, I'm sorry, 21 plus 6. I said the answer, 27, yeah. 7 times 1 plus 2 is 9. Now, do I have to go and do all of these zeros down this direction? No, because what is 0 times anything? 0. So I don't have to go add those zeros down. Let's see what happens to our answer, though. How many decimal places do I have here? 2. Okay. How many do I have on my second number? I have 3. So that means in my answer, how many decimal places am I going to have? 5. All right, remember, I'm always going to start from the right. So I'm going to move 1, 2, 3, 4, 5. What happens now? I do add a 0. Think of this as like an egg carton. You go to the grocery store. Do you open? Okay, well, it could happen, but you don't want it to happen. Do you open an egg carton and there's eggs missing? You don't want that to be. Well, it could, but that would be kind of weird. I wouldn't buy them if that were the case. But if you open the egg carton, we want eggs in all of our slots. Okay? So if we look at this, this is our egg carton. We have to put a placeholder here because I have to have 5 decimal places. So 1, 2, 3, 4, 5. Now, I would have ended up having this 0 had I gone and multiplied everything else. But I have to have that placeholder to make sure my decimal's in the right place. Can somebody read that decimal? Not like 0.09765, but like we talked about yesterday.
9,765 hundredths.
Fantastic. Did y'all hear him? 9,765 hundredths, because we've got tenths, hundredths, thousandths, 10,000, 100,000ths. So again, first you say the name as if there is no dot, then you say the name of the last place value spot. So they're kind of hard to read sometimes, yeah. I could. Yeah, I absolutely could put. Now, if you did not I would not count off. But a lot of times people do like to put a 0 in front of the decimal because it's kind of like, hey, you know, don't forget me, I have something coming after. So it's kind of like a signal to say there's a decimal point here. But if you did not put that 0, it's perfectly fine. Yeah, but you can. All right, what about number 2? Which number do we want to put first?
They're both equal.
They are both equal, but do I want to multiply by 3 numbers or 2? 2. I kind of agree. Question?
What if we don't add the second 0? You would take that.
No, this one? No, you don't have to have it. That's perfectly fine. I'm saying it doesn't change the value, so you can put it or not. I'm good either way. Yeah, I agree. Let's put the 798 first. Times 0.65. Okay? That way we're only having to multiply by 2 digits instead of 3. What's 5 times 8?
40.
So we put our 0, carry our 4. What's 5 times 9?
45.
Plus 4, 49, carry our 4. 5 times 7,
35.
plus 4 would give us 39. Okay, now we do have another number to multiply. So on my second row, I put my placeholder. 6 times 8,
48.
carry our 4. 6 times 9,
54.
plus 4 gives us 58. And 6 times 7, 42, plus 5 gives us 47. Okay, do I need to do the next 0? No, it's unnecessary. Because I can always fill in that placeholder if I have to. Okay? 0 plus 0, of course, is 0. 9 plus 8, 17. Careful. Yeah. And that gives us 18, 11, and 5. Okay. So, again, almost 8, almost 800, almost 1. So our answer, reasonable answer, should be somewhere around 800. That says 51,870. We know that's not reasonable. How many decimal places after the decimal in this number? 0. Guys, where is my decimal on this number? There is, but where is it? At the end. So there's nothing after that decimal point. What about this one? 2. So in my answer, there should be 2. And again, you don't have to do these blocks. I'm just doing this as I'm explaining it to you so that you know why I'm getting this number. So we move it to the left 1, 2 places. Now, 518 and 7/10. Is that a little more reasonable? Absolutely. Okay? All right, any questions so far?
No, ma'am.
All right, fantastic. Let me stop this.